Hey, I'm 218. Let's take a look at section 10.1. So this section really has one theorem. If a radius of a circle is perpendicular to a chord, then it bisects the chord. So here's my radius, and here's my chord. Basically what it's saying is if this radius is perpendicular to this chord, so there's my right angles, then it also bisects the chord. Okay, the converse is also true, so basically it's saying these two go together. Okay, if you see the right angles, then you see the bisects. If you see the bisects, then you should see the perpendicular and the right angles. Okay, so let's put this theorem in context. Here I'm giving you circle D. There's D is the center of the circle. I'm telling you the radius of the circle is 25. Okay, next I'm telling you that the length of chord AB, so the length of that segment, is 14, and I'm telling you that AB and DC are perpendicular. So since these guys are perpendicular, I know that the radius also bisects the chord. Okay, so we've got to put some numbers on here. The first number I'm going to deal with is the 14. The 14 spans this pink segment right here. So if the whole thing's 14, obviously each half is 7. Okay, so let's pay attention to this next part. I have a radius of 25. Everybody's initial gut instinct is say, okay, well I have this radius right here, this purple segment, let's make that 25. And that's true. This purple segment is 25, but that doesn't help me solve this problem. What's going to help me solve this problem is to draw in segment DB. Okay, so if I draw in segment DB and I put the 25 there, that's what helps me solve this problem. Because now, if you look, I've got a right triangle here. And in fact, I even have a right triangle that's a triple. How lucky for us. Okay, I see 7, 25. I know that DC has to be 24, and I'm done. All right, last example. So let's take a look at our given. I am again giving you that D is the center of the circle. I'm again giving you that this purple radius is perpendicular to the pink chord, which means if it's perpendicular, it also bisects. So remember, those always go together. Okay, I've given you some distances here, and I'm asking you how far, let's put a segment marker on there, how far is segment AB from point D? So look at how I've worded that. I've made it look like it's a distance, and that's exactly what this is. Segment DC, okay, because segment DC is perpendicular to my chord, that is the distance of this chord from the center of the circle. So again, anytime we measure the distance to the center, we're going to use a segment with a right angle in there. So I'm asking you how far is this segment from the center, which asks basically for the length of DC. Okay, so putting my numbers on there, again, I kept AB as 14, so it splits into 7 and 7. This time I gave you that CE is 3. How does that help me? How does the fact that CE is 3 help me to find DC? I don't have a radius. If I draw in my triangle, I'll be missing two sides. Okay, drawing in segment DB or DA, drawing in that radius, that's exactly what I want to do. So even though it looks like I'm missing two sides here, here's how I'm going to approach this. I'm going to let DC be X, okay? Which means now that my radius from D to E is the quantity X plus 3. So now I can call this side X plus 3. Sorry, it's a little messy. And I'm going to do Pythagorean theorem here on this triangle. And you thought triangles were last chapter and you were done with the Pythagorean theorem. Okay, Pythagorean theorem says a squared plus b squared equals c squared. Some good algebra, remember you have to FOIL that side out. Do not just get x squared plus 9. Collecting like terms, okay, the x squareds drop out. Solving, I go ahead and get x equals 46, which reduces to 20/3. And x, remember, was my answer. So DC has a length of 20/3. Now the only other thing I could point out is that be careful on how I word the question, because I might ask you for DC, but I might go ahead and say, well, find the length of the radius. So if I ask for the length of the radius, you would just have to add 3 to that 20/3. Okay, this time I just asked for the length of DC, so really, we are done.